Alrighty, everybody. It looks like we just got our okay to start our planetarium show. So I'm gonna be putting away the space trivia questions because now we're gonna be heading into the unknown. Ooh. And also, once again, folks, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter, and I'm very excited to have you here because you're my favorite place in this entire universe, which of course is the Morrison Planetarium. And everything that you see in purple right now is going to be one enormous screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for those projector systems, they're hidden just below the purple glow. Also, if you're looking for me and where my voice is coming from, well, I'm standing right behind you. I'm at the very top of the planetarium. Hey, good afternoon, everybody. Just want to let you know that I'm here. I'm an actual person, not a robot. And I'm very excited to have y'all here because we're about to do my favorite show in the planetarium, which is called Tour of the Universe. And with Tour of the Universe, the show is completely live. You're going to hear my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. But before we get started with our show, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's a few of us here. First off, folks, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We really do appreciate your help. Also, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now's the time to turn them off, put them away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. Also, folks, if you need to exit early during our show, you're more than welcome to do so. All we ask is that you exit towards the top of the planetarium. That's where you can find the exits before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. Although if you have trouble climbing the stairs, don't worry, we understand. The stairs are very steep. If they pose a problem for you, once the show ends, just remain seated for a little bit longer. We'll have a staff member escort you to a lower exit as the show wraps up. And last but not least, folks, this show is quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across space, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, gaze into the dome before you, because we're going to start our tour of the universe. And let me just regain control of my spacecraft here. And folks, like I said, we're going to be starting off pretty close to the Earth. We can see all the city lights just down below. But we're starting right here at the spacecraft in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct all different types of science experiments that they wouldn't normally do on the Earth, which has a lot of gravity. Some of the things that they'll experiment with are things like what happens when you try to grow plants in space. Do the plants grow the same with less gravity? Which way do the roots grow? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And another one of the experiments that I really do like is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrasted the two. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long time, remember to exercise daily. And folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. And if you've never been to an American football game before, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big it is. And also, what's really impressive is that this thing is going really fast. The International Space Station is traveling at a whopping speed of 17,000 miles per hour. 17,000 miles per hour. Whew. It orbits once around our Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew. How romantic. And also, folks, this looks really far away from our planet, but it's not too far either. It's only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. But to tell you the truth, this is as far as we put humans into space nowadays, because traveling into space is very expensive. You gotta buy yourself a rocket ship or build one yourself. And then once you do that, you have to account for a lot of rocket fuel. You're gonna need so much rocket fuel, you gotta be able to escape the Earth's gravity. Once you accomplish that, you have to also account for all the food, water, all the air you're gonna be breathing while you're up here in space, so the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're gonna see it slowly disappear to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. So here comes that orbital path, and let's zoom on out. And now, folks, we're now able to see our entire planet Earth. And I want to let you know that the space program that we're using in here in the Morrison Planetarium is something that you can go home and download if you want to fly through space just like how I am. The space program that we're using is something called OpenSpace Project. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across the link where you can download this. And it's a whole lot of fun. But just a heads up, OpenSpace is in its beta phase, which means it's not completely finished. We may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, OpenSpace uses a whole lot of processing power. So if you have an older computer, it may overwhelm that computer. But if you got something new or a gaming computer, give it a try. It's a whole lot of fun. But if you're like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes. So if you go to your favorite search engine, type in NASA's Eyes, you can come across the link, don't have to download anything, you can fly through space, and it's so much fun. So we have OpenSpace Project and NASA's Eyes. But now that we got a good sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before, but that was a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun as well. They got to play some golf up here. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years thanks to a new space mission by NASA called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone about how we're going to be figuring out the logistics of living out here in space, because it's relatively close by. And what's also impressive is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, and we're able to conduct a lot more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found a whole lot of ice there, and ice is going to be very helpful because if you pass electricity through that ice, once you melt it, you'll get hydrogen and oxygen, and those are both very useful, especially when you're out here in space. So again, we humans should be heading to the moon in the next few years. Crossing my fingers, and look out for any news about Artemis in the news. And folks, when we look up at the moon here from planet Earth, sometimes the moon feels incredibly close to us. Feels like you can reach out your arms and touch it. But the moon's incredibly far away. It's about 240,000 miles away from the Earth. 240,000 miles? Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it takes light only 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say, bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth's orbit as they start to slowly recede. In fact, let me add some nice planet trails so we can see where everything is in space, because again, space is really big. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to help of computer models like OpenSpace showing us the most accurate images and information available to us. And now, the nearest star to us, the sun, should be coming into view in any moment. So, here comes the sun. Do 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 do. Hey, there it is. And again, folks, the sun is also incredibly far away from us here on Earth. The sun's about 93 million miles away from our planet Earth. 93 million miles. That is a great distance away. And again, we're the third rock from the sun. So 1, 2, 3. Third one right over there on the left-hand side. But in terms of speed of light, 93 million miles isn't too far. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light to cross that 93 million miles. So only 8.5 minutes. Not too bad either. But now that we have a nice bird's eye view of our solar system, let's get a quick refresher of what's here, because there's a lot of good stuff in our solar system. Right in the middle is our star, the sun, the biggest thing by far. Closest planet to the sun, we've got Mercury. Right after that, we've got Venus. And then, of course, third rock from the sun, we have Earth. That's us. And then after Earth, we have Mars, the red world, the red planet. And then beyond Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like here to highlight all the asteroids in our asteroid belt. There is a lot of them. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all. After that, we have Saturn, famous for its rings. And then now we're going to encounter the icy gas giants. We got Uranus, the funny one, and Neptune right over here. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto, just over yonder in the back. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So this is the Kuiper Belt, folks, and you can kind of think of it like a second asteroid belt. What you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And pretty much our technology has greatly improved, and in 2006 we found all these objects out here in this Kuiper Belt region. And that's the really cool thing about science. As our technology progresses and gets better, our telescopes are able to see much smaller objects much further away. So who knows what we're going to find in our own backyard in our solar system in the next 10 to 20 years. Maybe there's way more stuff out here that we're able to see at the moment. But for now, I'm going to be putting away the Kuiper Belt region because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen so many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction as we fly by Pluto. Now, just to let you know, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Not too bad either. But folks, it's time for us to leave the planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. So let's continue zooming on out. And it looks like Alpha Centauri is going to be the one just down below. Always want to make sure. Zoom out just a little bit more. And yep, there it is. So folks, Alpha Centauri is going to be just a little bit on the bottom right over here. You can see that star moving really close to us. We're right in the center. That's our star system. 4 years at the speed of light just to reach the next star system to us, Alpha Centauri. But that doesn't really put into perspective how long it would take us humans to travel that distance. Well, folks, if you're to get in a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to make that trip. Whew, and that's just a one-way trip. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And once again, folks, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? And right now, folks, I'll be adding some many markers onto the screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets just in the nearby vicinity to us. 5,000 other worlds besides our own. Whew, that's a lot of planets. Now, to say if any of them are Earth-like with conditions suitable for life, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed and created, so we got a few years before those are figured out, constructed, and then launched into space. In fact, you can see we have space telescopes right now where their whole purpose is to find as many exoplanets as possible. So on the right-hand side, we point our space telescopes in one direction, and we found a whole heap of planets. So as they continue to scan more and more of the night sky, that 5,000 number is going to be going up. But again, we're going to have to wait a little bit longer to figure out if any of them are Earth-like. So give it another 5 to 10 years or so. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the left-hand side of our radiosphere. Let's say this one on the left. And then we find an alien civilization somewhere towards the middle. Let's say over here. We shoot them a text message. We say, hey, we humans, we live on this rock. It takes 60 years to get to them. They listen in, and then they reply, another 60 years. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. And of course, folks, planetary systems beyond the radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away the exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So keep your eyes on that radiosphere as we continue zooming away. Alrighty, everybody. Now we've zoomed so far out, we're now able to see our entire galaxy, the Milky Way galaxy, the one that we live in. And I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you want to cross it from one side to the other, it's going to take you about 130,000 years just to cross it once. So really, really big. And our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. So if we fly on over to the side, you're going to notice that our galaxy kind of looks like a big pancake or a frisbee in space. It's really flat on the side. And this is important because when scientists and astronomers want to learn about the universe, they need to point their telescopes galactically north and galactically south instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe, because that's a bunch of stuff blocking their telescopes. So again, they like to point their telescopes galactically north and galactically south. It's much easier to see things. But keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture starts to expand, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies, or voids where there's no galaxies at all. So we can see some nice galaxy clustering right over here, down in the center. We can see some on the top left-hand side. We can see very few or no galaxies on the very top right of our screen, our dome. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, the picture that we're looking at right now represents the closest 30,000 galaxies to us over a space 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation thanks to the work of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. But folks, we now have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew. And remember when I mentioned that we live in a flat spiral disk of our Milky Way galaxy? Turns out the large scale structure of the universe is not in the shape of a bow tie or a butterfly. If we were to line up our Milky Way galaxy, it would line up right down the middle, just like so. So again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which runs right down the middle like this. But scientists still want to make sure that there was galaxies through the plane of the Milky Way, so we have this nice purple survey of galaxies. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet, so it's just a matter of time. But folks, it looks like we're running drastically low on our tour of the universe. 30 minutes is just not enough time to talk about the universe, to be honest. So let's continue pressing on because we still have a little bit of ways of go. And now we're going to be encountering these really distant, faraway objects known as the quasars. And folks, the quasars are going to be represented by these nice orange dots at the very edge of the large-scale structure of the universe. We got some quasars on the left, we got some quasars on the right-hand side, and quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe. This is what we like to call the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't a typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny, minute differences eventually gave rise to the large-scale structure of the universe that we saw moments ago. That clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to head, which is going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies, and let's make our return trip back to planet Earth, everyone. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes and preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're now entering our Milky Way galaxy, folks, and we're heading straight for that radiosphere. And now we're heading to our small little neighborhood, our own solar system, our star system amongst the many in our Milky Way galaxy. And now we're about to pass the spacecrafts we sent out in the 1970s to explore our solar system, passing the Kuiper Belt and the orbit of Pluto. And we're making our way to the third rock from the sun, our homeworld, planet Earth. And as we make our final approach back to planet Earth, folks, just remember all the people that we know, everyone that you've ever loved and learned about in history, all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And again, as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound, back to planet Earth. And that's all for today, folks. Thanks for stopping by, and make sure to get home safely.